sine t liters per hour. During the same interval, water flows into tank B at a rate of B of t liters per hour. Both tanks are empty at time t equals 0. The graphs of y equals a of t and y equals b of t, shown in the figure above, intersect at t equals k and t equals 2.416. How much water will be in tank A at time t equals 4.5?
Okay, let's draw the line at, arrow at sign. Because we're using trig function, your mode has to be in radian mode. Let's all double check, even if you have. So typically it could be in degree mode if my geometry kids use the calc. If you have your own, it should always be in radian mode. And then our goal is to save time on the AP test, right? When they give you an equation, you don't want to be typing that in every single time. So let's do this. Let's type in all of A of t into y2. And we're saving y1 because it's a smart idea. So on y2, exactly as you see, but in place of t, you're putting an x. And then we have 5 e to the power of 2 sine of x. Exactly as you see. Except the t after the sign, it'll automatically populate a parentheses. Okay? So anytime I need this equation, we're going to use vars, y-vars, functions, and so on. So here I go. This one has to do with the flashcard number 5b. And let's see how we actually use this. If I give you a function, would you agree the rate is the derivative? So what I gave you is a of t is the rate. If I want to find how much water flowed, the amount of water flown in, it's going to be our original function, which means it's the integral. So let's put on here how much water is going to be the integral of a of t. And to find the integral, don't we have our calculator for that one? Math number 8 or 9? 9. So the way we're going to type this in is going to be from 0 to 4.5 of a of t dt. And the cool thing about this one, the a of t that they already defined, you don't have to write that down. You don't have to waste your time on it. As long as the AP test initially has it defined, they'll give you that credit. So exactly as you see on the home screen. Go to Math 9. Oh, why would I do that? I don't know. Math 9. We have our lower bound is 0, upper bound is 4.5, and I'm going to do my function. Vars, and then where do I go? Y-vars, function, and I'm going to select what? Y2. And look what I did again. I forgot to write dx. I keep doing that. I'm going to blame it on me rushing. And that's going to give you some value of 66.532. So here's the idea. When they ask you a simple question like this, and your space looks pretty blank, I would always write this in a sentence format. And our sentence format is going to say, tank A at blah, blah, blah. So let's write this as a sentence. Tank A at time t equals 4.5 contains, you can rephrase the word contains, has, that's up to you, 66.532 liters of water. And again, the word you're avoiding is it has. It has that much. All the pronouns we want to try to avoid. Okay, let's see how we want to grade this on the AP test. Having this value over here, that you know is the integral, that's going to give you 1 point. And your final answer with 66.532, saying at time, with the liter of water is going to give you 1 point. So your goal is to say as much as possible. Okay? All right, let's go on to part B. Ian, let's read part B.
During the time interval, 0 is less than or equal to t is less than or equal to k hours. Water flows into tank B at a constant rate of 20.5 liters per hour. What is the difference between the amount of water in tank A and the amount of water in tank B at time t equals k?
So A of t is a rate, 20.5 is also a rate. So I need to integrate both of them and subtract it. Let's look at the picture. On my picture, I'm going to kind of differentiate it with the picture. Highlighter. Here's my B. And here's my A. Would you agree? Area under the pink is greater than the area under the blue? Yes? So I'm going to integrate the pink minus the integration of the blue. Now, blue is A of t. Now, notice B of t, there's no equation. That's why they gave us a rate already. So let's put on here, we need to figure out, what is this K value? Let's all put K. And to find that out, what you're going to do is put in 20.5 into our Y1. That's the rate of our B value. My A value rate is already on Y2. And because we already have the graph, go to window. I'm okay with -1. The highest number on this value, y'all see 5 is the highest value. You can do more if you want. I'm going to do 5. And then Y minimum, I think I'm going to put -10, just see the bound. Highest number is 40. I think I'm going to do 50. Okay, did we all modify our window? The window was created from the given graph. Now go to graph. Now, if you don't graph this and find the intersection, your answer is going to be rounded as we go, which means there's a chance it could be incorrect. So our graph kind of looks like it. So I'm going to go to second calc, 5. And then I'm going to go to the intersection, inner 1, 2, and 3. And that number, I'm going to put on here, my K value is about 0.892. Let's do something. We are going to store this number as K. So not sure if you guys ever were aware. If you type in X, it's going to remember the last intersection you typed in. So if you did not intersect with me, you're not going to get to this. And store button is next to the number 1, store. And I want to use the same variable just so that my brain isn't confused. So anytime I recall K, it's going to be that ugly decimal. What's up?
Where's the store button?
Store is, it says stow.
Oh, okay.
Okay, let's write in what I know. The integral of 0 to K of 20.5 dt minus the other integral since we're looking for the difference. And then it's A of t that we're not going to type in individually since we already saved it. So we're going to do math 9 how many times? Twice. So we have math 9. The first one is 0 to K. It remembers what the K value is. So it's not a variable anymore. 20.5 dx minus math 9. 0 to K again. And then we already saved our equation, so vars, y vars, function, and select y2 of dt or dx. Go ahead and press enter. Did you get 10 point something? Yep. So let's do 10.599 as a 10, not a 6. Again, let's write this in sentence. They love it in sentences. I'm going to say the difference between the amount of water in tank A and tank B. I think I'm going to skip the amount of water twice. At time t equals K. So let's copy that piece. The difference between the amount of water in tank A and tank B at t equals K is 10.599. And what's the units on this one for the water? Liters. So let's look at our point system. Knowing to integrate 20.5 is going to give you 1 point. Also, knowing to integrate A of t is going to give you another point. And then writing the whole phrase with the key words will be 1 point. There's something ambiguous. Is it clever for me to leave t equals K? Or should I change that? Have I already defined what K was right here?
Yes.
So if I define it, you don't have to say it anymore.
Oh, okay.
Okay? Now, if you did not define it and you just did it all on the calculator, you'll need to type it in or write it out.
Do you
Yeah.
have to derive 20.5?
You mean integrate?
Or do you already integrate?
Yes, because 20.5 was a rate, and I wanted the amount of water in tank B.
But they say it's a constant rate, so it should be a straight line.
It's still a rate, though.
Could you just multiply it by?
It is still the rate.
Oh,
But I get what you're saying, though.
okay.
All right, you can derive by hand on this one, though, too, right?
Right.
Yeah. Let's go on to number 3. Okay, for number 3. In my opinion, I think 3 is a little more intuitive than number part D. Okay, Angel, going to be part C.
The area of the region bounded by the graphs of y equals AT and y equals BT for k is less than t is less than 2.416 is 14.470. How much water is in tank B at time t equals 2.416?
Okay, here's the annoying part. We have this graph broken down from 0 to k, and k2, 2.416, right? So I need 2 integrals. So let's put on here, let's do a quick reminder. K is equal to 0.892. It is already saved, we stored it. So let's write integral from 0 to 2.416 of b of t. So we're going to need the integral from 0 to k of b of t. That's the first portion. Oh, what did I put an equal to? That's a plus sign. And then I need integral from k of 2.416 that we need a lot more information on. Okay, we do know b of t is going to be the integral from 0 to k. We already know that part. dt. Did y'all realize I forgot dt right there? Don't be like me. All right, I want to focus on this guy right now. Everybody circle that with a different color if you can. And I'm going to reiterate what that basically means in the picture. So go back to your picture. In my picture, it's telling me, I want you to find the area of this guy over here. When I know the area of the top piece is 14.47. So I'm going to break this down into 2 different drawings. Let's say I have this one. And I have the whole drawing, and that's A of t. And then let's say I have my partial, and I'm going to put a dotted line. And that amount is 14.47. So here's the idea. I need all eyes on the board. Would you agree? If I take all of this and minus that small portion, it's going to give me that bottom portion?
Yes.
So I'm going to write A of t minus 14.47 is going to give me B of t. Let's put that in our equation. So in our equation we have on here, we have A of t, integral I mean, from k to 2.416 of A of t dt minus 14.47. And all that is representing B of t from k to 2.416. And at this point, all we have to do is type everything in the calculator exactly as you see. So type with me. So I have math 9, 0 to k. K is already saved, which is kind of nice. And then we have 20 point, did y'all realize it should be 20.5 right there? 20.5 dx. And then we have added math 9 again. This time we have k to 2.416. And let's do vars. Y vars, function, recall y2, dx, and at the end, minus 14.47. We're all typing it in. I see 2 people typing. And in case you can't see the whole row on the calculator, it is the last row on my paper. So we're collecting more volume, so it should be more than the initial. Okay, Ian, did you already press enter?
Not yet.
Not yet. Lauren's about?
Yes.
Okay, let me know when.
I don't know how you did the DX right after.
DX at the end?
Oh, I see.
And I hope to get 40 something. Yep. So we got, that was, I'll put it over here, 48.314. And again, we want to use our sentence stem. I'm going to write tank B at time blah. So tank B at time t equals 2.416 contains or has, accumulate, up to you, liter of water. Okay, let's break this one down. This one's a little stingy, and I want to make sure we have the right amount. That was 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, this one's a little stingy. Understanding this guy over here, the big minus small is going to give you 1 point. And then the whole phrasing with the important key points will give you another point. Again, don't say it has. Okay, y'all good with this one? Last one? Okay, Abby, when you're ready, let's read part D.
During the time interval 2.7 t to 4.5 hours, the rate at which water flows in a tank B is modeled by W of t equals 21 minus 30 t over t minus 8 all squared liters per hour. Is the difference W of t minus A of t increasing or decreasing at time t equals 3.5? Show all the work.
So we're looking for the difference. I want to double check on something. There might be a mistake. Is the difference increasing or, oh, okay. So let me go back to my flashcard. Oops. Where'd it go? Here it is. So here I have the integral, not integral, the derivative. So I have those two are actual derivatives, right? They're both the rates. So if I want to figure out if this rate is increasing or decreasing, I could find out they're increasing if the derivative of that is going to be positive or negative. So if that's already the rate, I'm going to use my single prime. If that was already a prime, I'm going to use my double prime. But in this case, this right here is already the prime. So I'm really looking at when W prime of t minus A prime of t, is it a positive or negative? So if it is positive, it's increasing. If it is negative, it's decreasing. And again, it's going to be purely on the calculator. So we're going to type in W prime of, they gave us 3.5, minus A prime of 3.5. Let's type that in. The only one requiring us to type is our W. That's our new equation. So let's go to, this one is derivative. So where do I go? Math, 8. And I want to find it at 21 minus alpha y equals 30x. We have x minus 8 on the bottom. Should be in parentheses because it was all squared. And our value is at 3.5. And then minus math 8 again. And this time we're going to call out the vars. Okay, for time's sake, I'm just going to press enter. We get negative 1.143, that's less than 0. So because it is less than 0, is it increasing or decreasing? Decreasing. So let's go ahead and use our sentence stem. The difference of blah, blah, blah is decreasing at time blah, blah. So we have difference of WT minus A of t is decreasing at t equals 3.5 because W prime of t minus A prime of t is negative. And then our point system, finding that it is a negative value, the whole thing is 1 point. And the phrasing with the key concept is going to give you another point. And let's make sure that together is 9 points. So that's 4, 5, 6, 7, 8, 9.
What's the last word?
Negative minus with the apostrophe VE. So on your number 2A, right on top, I want you to write over 9. How many was raw without my help? How many was it with the help eventually? Potential.